and sound. The world of light and sound. Every day we see beautiful, strange, and interesting things. Think about the many things you've seen today. Maybe you noticed the sky. Was there a bird in flight? Were there clouds covering the sun? Was the sky a bright blue or a dull gray? The truth is that you were not actually seeing any of those things. You were only seeing light. Light comes from objects both near and far. That's what you see. In fact, that's what you're seeing now. How about everything you hear? What do you hear now? Even in the quietest places and times, you can hear things. Maybe it is soft breathing. Maybe it is pages turning. Maybe someone is blowing her nose. When you hear those things, your ears are picking up sound vibrations. For most people, light and sound are two of the most important ways to know the world. Through light, we see. Through sound, we hear. Importance of light. Can you imagine life without light? Each morning, sunlight floods into your bedroom. Throughout the day, we use light to help with nearly everything we do. Light helps when we work and play. Without light, everything would be more difficult. Before people knew how to use electricity, they planned their time around daylight hours. They used fire for light at night. Candles and stove fires lit the world. Later, oil and gas were found to be good fuels for making light. What is light? Light is a form of energy. Energy is the ability of a system to do work. The power of light is obvious to the eye. The energy of light is called radiant energy. To radiate means to send out rays or waves. Only a certain type of radiant energy can be seen with the human eye. We call this visible light. Visible means that we can see it. Natural light comes from natural sources like the sun and other stars. Other light sources are artificial. People make them. Lights in a home or the headlights of a car are sources of artificial light. We can see because of light. Light bounces off objects and travels to our eyes. Our eyes and brain work together to translate that light into what we see. The sun. The sun is Earth's main source of energy and light. Without sunlight, there wouldn't be enough energy to heat Earth. We couldn't survive. Even if we burned all the fuel on Earth at once, it still would not keep the planet warm enough for life to exist. Did you know that sunlight produces power? The sun's energy can be used to make electricity. This is known as solar energy. How light is made. Everything is made of very tiny particles. They are called atoms. Whether something is big or small, solid or liquid, or light or heavy, atoms are its basic parts. Light can come from excited atoms. Heat causes atoms to become excited. They move faster. Some excited atoms radiate light. Have you ever seen the bottom of a pan that is heating on the stove? Did it look like the hot pan was turning colors? When heated, the atoms on the surface of the pan start to bump into each other. This causes them to give off extra energy. This radiant energy is what scientists call light. Light travels in waves, much like water moves in waves. The amount of energy that a wave carries determines the color of the light. Waves differ from each other in length, rate, and size. These are called wavelength, frequency, and amplitude. Wavelength relates to the color of the light. White light, the combination of all colors, is white light. What do they mean? Peak, the top of a wave. Trough, the bottom of a wave. Wavelength, distance from one peak of the wave to the next. Frequency, number of times per second that peaks pass a checkpoint. Amplitude, the height of the wave. The speed of light. Light travels through empty space at the rate of about 300,000 kilometers or 186,000 miles per second. Reflection, refraction, and absorption. What happens when a light wave hits the atoms that make up everything? Several things might happen. The light can change direction or refract. Some of the light rays can reflect off of the surface. The light can be absorbed into the material. Light rays bend as they travel through the surface of transparent material. Transparent means that light can be seen through it and move through it. This bend in the light is called refraction. It occurs when light travels through different materials at different speeds. The return of a wave of energy after it strikes a surface is called reflection. Smooth and polished surfaces like mirrors reflect more light than surfaces that are rough or bumpy. When light reflects from a smooth surface, all of the light rays reflect in the same direction. A mirror is smooth, so you can see your image in it. When light reflects from a rough surface, the rays reflect in many directions. It is impossible to see your reflection in paper because the surface is rough. As the light passes through the glass, it slows down. When the light passes through the water, you can see the straw appear to be cut in half. Optics. Optics is a branch of science that examines the behaviors and properties of light. Scientists have used their understanding of optics to invent many important devices. Microscopes allow us to study very small objects. Telescopes allow us to study objects far away. Optics allows doctors to prescribe lenses, glasses, to correct our vision. Binoculars, magnifying glasses, and cameras are examples of other optical devices that aid our vision. The science of optics plays an important part in our everyday lives. When it comes to color, absorption is the key. Look at the clothes you're wearing. What colors are they? The truth is, the colors are not in the clothing. The colors come from reflected and absorbed light. We see the colors because of the light that is reflected and sent to our eyes. You know that light is made of waves. Each color has its own frequency. When visible light strikes an object, each frequency behaves differently. Some frequencies are absorbed, they are not seen. Some are reflected. The reflections are what appear as the color or colors of an object. White light is made of all the colors of the rainbow. These colors are red, orange, yellow, green, blue, indigo, and violet. Some people know the colors as Roy G. Biv. Now look at something red. You can see just by looking at it that the object absorbs the frequencies for Oi G. Biv, but R, or red, is reflected. Your eyes pick up that reflection and you see the object as red. The important idea is that the color is not in the object, it is in the reflected light. Light through a prism is broken into all the colors of the rainbow. The eye. The human eyeball is small. It measures only about 25 millimeters, 1 inch, wide. Even though it is small, it plays a big part in everything we do. It is the organ that gives us sight. We use our eyes to work, read, watch movies, play sports, and find a friend in a crowded schoolyard. Really, the eye does not see objects, it sees light. Objects reflect light waves in all directions. The light rays enter the eye and change into signals. These signals are sent to the brain. The brain sees the objects as visual images. Light and bright. Let's shed some light on light and knowledge. People who are intelligent are sometimes called bright. A light bulb often symbolizes a good idea. When someone teaches others about a subject, he or she illuminates them on the topic. Do you see what I mean?